Hey, William, how are you? This is Miguel.
Hello,
I'm the
Miguel.
faculty in charge of the team. Thank you
All
for
right.
joining us today.
Oh, yeah, my pleasure. I always like looking at rockets. So,
Yeah, me too, and also our team. Yes, so I think it's just missing one more person, and then we can get started.
that's fine.
It's just for our reference. So you can see.
Hello.
Traffic. Oh,
I've been reviewing rockets from all over the world, but you guys are probably the closest to the actual launch location. So you don't have near the logistics of travel that I'm seeing with other teams.
I bet, yes. That we're lucky enough to have around is only a couple of hours from us to get to Spaceport America.
Yes. Yes.
And also for us, it's easy to do a TED launching before going to the competition here in Horizon. So it's about 40 minutes from the campus.
Yeah, and it doesn't hurt that you're already acclimated to the weather. So,
well,
yeah.
believe it or not, it's still kind of challenges to some of us.
Oh yeah. I mean and that's one of the things I really emphasize, with everyone going there. The New Mexico desert doesn't care where you live. It doesn't care where you come from. If you don't stay hydrated, it's gonna kill you.
Yes.
So.
Yes.
Yeah.
Spaceport America last year was really rough. It was a lot of wind.
Yeah, it was intense. Yeah. I'm trying to remember. Was it Friday? I mean, there were like 3 or 4 rockets that almost launched horizontally. They looked more like missiles than rockets because it was windy, and if you have a stability greater than, let's say, like 4 or something like that, they just weathercocked right into the wind, and they were gone. So
yes, that might be right, because Thursday, the day that we launched, the afternoon, it was super windy. I mean, a couple of rockets pretty much blew up and went in the sky. But
yeah. So I don't know if any of you recall, there was a dust devil that kind of hit the launch area.
Yes.
I was standing out there when that happened, and I couldn't see the people standing right next to me. So
I actually recorded a video.
You probably have video of, well, not really a video of me. You have a video of the dust cloud that I'm in.
Yes, pretty much. Yes.
Yeah. Okay.
It was interesting. All right, I think we're
set. Yeah. So okay, fantastic. And I know that you're. I can see the parts of your rocket back there that you still have some work to do on it, and that's completely okay. The main purpose of this is just a safety review, so that if we find any big things, you have an opportunity to work on it, versus showing up on the Tuesday when you do the safety review, because you will do another safety check on either Monday or Tuesday whenever you can get in that room. And it's much better if we can find things now and give you time to work on it, versus finding it the night before you go to Spaceport, and then you're up all night. Also, I've been out on the launch pad before where you're launching, or you're helping students put rockets on, and you can feel that the paint is still wet, and it's like, come on, let's get this done in time. So I'll leave it to you. By the way, are you recording this?
Yes, the meeting has been recorded.
Okay, yeah. Fantastic. I just want to make sure, we've had a couple that we forgot. So it's entirely up to you whether you want to start at the Bernie end or the pointy end and just go across the whole rocket and talk through it as you go.
Yeah, so I'm going to introduce to you, maybe you already know, Andres is and Pedro both are in charge pretty much of the team leaders. The rocket team, and then we have officers and that works independently in their own sub teams. So yeah, I'm gonna let the floor talking to Andres and Pedro so they can navigate us where we are.
Sure thing. So right now we've just recently received the last shipment of our airframe pieces, which happen to be our nose cones. I'm not sure if you're aware, but this year we will be attempting the 30K COTS category. That is a new category that's for our team. This is in fact our third year competing, but it is our first year in the 30K category. As far as shipments and any delays of pieces or pieces that we're required to build a rocket, right now we're looking good. The only remaining big major factor on the construction of the rocket remaining is definitely the transition that we will be using, because we have two different diameters on our rocket.
Oh, cool.
And right now we're seeing a piece of aluminum for our transition there. We'll get into more details on that later on in the meeting, but just as a quick overview, overcap, it's just pretty much assembling all the pieces, since it's, everything's just been purchased, so it's just putting it all together. I know we've been working on our payload as well, and then I just got a last report from our payload that we're about 85 to 90% complete with that as well.
Fantastic.
Apart from that, I think we have recovery. We just got our last pieces as well, our parachutes and our tender descender. We will be utilizing the same system that we used last year of the Raptor system. I'm looking around here. We don't have so Damien, he's actually our recovery expert here, but we will be reutilizing the same system that we used last year, as it proved to be effective. We did make some revisions to the parachutes and the packaging assembly, because we did run into some issues in the last competition where we had some entanglement issues and some high speed of deployment. So we had some ripped up strings from the parachute. But that was the only anomaly that we had from last year's recovery.
Have you practiced reefing, like with subscale rockets or anything like that? Do you have some experience with the tender descender?
So the tender descender, we really only utilize on the main test, which we will be conducting as soon as possible. The target day was actually supposed to be today, but we will have to push it back because of the delay that we had with the nose cones. But in terms of practicing the tender descender, we do some ground tests, as far as I'm aware of. We do multiple of those to make sure our igniters are working, telemegas, all that stuff. But in terms of an actual in-flight test, we reserve that for the test launch.
Okay, I mean, a lot of amateurs use them successfully, but it is kind of a challenging way to rig your chutes. So if you can get some practice on that, fantastic.
We sure will with our practice tests, absolutely.
Mm-hmm. Yep. Okay. This transition piece, are you having that done like at a local shop or something like that, or do you have the shops necessary to turn metal?
I can talk a little bit about this. So
Sure.
the CNC lathe that we have here at school doesn't fit the piece, so we had to outsource it. It's actually a shop about 20 minutes away from the school, so it's not that far. We expect to have it by Monday of next week, but in these things, the expectation it never really
right. Yeah.
hits the point. So yeah, we're doing hits here in El Paso, but not at school.
Okay. So, well, I mean, that's good, because I remember last year there were a number of teams that they had parts that were finished, but they were, they had to rely on DHL or some shipping company to get it to them, and got down to the 11th hour, not being able to have things ready. So good that you found a local source that can do that. And I can also tell you, I mean, I work at Iowa State University myself. It's not uncommon for the CNC machines that are available to students not being able to handle the diameters of a big rocket. So I'm looking at what I see behind you there. I'm not seeing the booster section with your fins or anything like that? Is that yet to be manufactured?
Yes. So most of the parts were actually we built most of the rocket in the past 2 weeks since classes finished and it was finals week.
Yep.
So we got most of the work done. Can you join the meeting? So you can get a closer look. But we do have the fins. We have all the components manufactured except the transition. It's just a question of either bonding them together with epoxy or welding some of the components. We know that it's going to be a little bit of a little tricky because it's going to be TIG welding, but we know we do have someone that knows how to TIG weld, so that person is going to be helping us with those components. Camera.
Yeah, it's on here.
It's on.
Just click it. On.
Okay. I don't know if it's. Can you still hear me? If
I can hear you. I can see that that's a good arrangement you've got there.
Okay, so I laid down the components more or less so you could see everything pretty well. So we have the two fins. So they have a span of the three fins. Sorry, they have a span of 4 inches. A tape cord of I want to say close to 4 inches too.
3.9.
3.9, and the root cord is about
15.7.
15.75 inches. So these are going to be welded to some rings that I have on top.
Oh, okay. I can see that. I lost sound.
Hey, I think you're muted, Pedro. It says it's muted. There we go.
Oh, you're already muted? Okay.
Yep, there we go. So I'm
Okay, that's better.
imagining that you're welding the fins to those rings, and then I can see the cuts in the fiberglass that you're just sliding the whole, I guess you'd
Yes.
call it fin can, directly into the booster.
Yes. So we have our motor mount tube, and that's where the rings with the fins will slide to, and we'll bond those to the tube to secure, or to assure that it's going to be secure. That was one of the questions from last year that I remember the most during the final safety meeting. So we will secure these rings with the fins to the motor mount tube, and then this whole section will slide into the upper part of the rocket.
Okay, I'm seeing one cylinder there that has like a lip on that. Is that kind of your thrust plate that goes across the bottom of the booster? Yeah.
Yes. So we're using a minimal diameter retainer.
Okay.
That it's on the inside already.
Oh, okay. So you're going to screw into the forward closure.
Yes.
Okay. All right. That's fine. Yep.
And then this will go in the back just to give us extra reassurance that the motor will be secured.
Okay. And then how is that fin can attached to the booster itself?
So to this booster, we have these angle brackets.
Yep.
And we actually haven't made the holes. We tested them this morning, but they will basically be mechanically secured to the fence. So we'll put 4 screws, and they will go through the fin to the other side, and then they will be also screwed into the airframe.
Okay. What can you tell me about the hardware that you're using to bolt that together?
I'm sorry, I'm getting a little bit of feedback.
Yep, I can hear that. Yeah, I'm just if you can. Oh, I can see it right there. I was just asking you about the hardware that you're using to bolt the fins into place.
So by the hardware you mean the
Yeah.
screws?
Yep.
Okay, so We initially wanted to use M6 screws, but we just chose to use M5 all around the rocket. So just for simplicity and to keep everything more or less the same.
Okay. I mean, is that a standard steel or is it stainless steel? I'm just curious about the shear strength of those screws.
That's a good question. Stainless? Okay, yeah. So they would be stainless steel.
Okay.
So we would onto the airframe. It would be more screws instead of the 4 that I secured to the fins.
Okay.
Another way that we're going to secure it to the fin, to the lower airframe, to the aft airframe, is since these rings are going to go slide inside.
Yep.
We have the opportunity to at least thread or make a hole and thread it and secure one of the screws through the centering ring.
Okay. Yep. That would make sense.
Do you have any other questions related to the?
No, and like you said, it's minimum diameter, so your motor is going to just slip snugly into that fin can.
So it this airframe is 4.5 inches in diameter.
Yep.
And this will be the motor mount that the motor fits snugly into.
Okay. All right.
So we have a very small diameter for difference of thickness.
Right, and that's why you had to really reimagine how you attach those fins, especially
Yes.
on a rocket that's going to be going so fast.
Exactly. So
Yep.
we expect around 23 Gs of acceleration. So most of the CFD we did, I want to say all actually, took into account the 23 Gs, and most of the amount of screws and but mostly the amount of screws was taken into account with the FEA simulations that we conducted.
Okay, so I understand how like those really thin rings are holding the motor tube. What is holding the motor tube to those?
So yes, so after the assembly of the fins and the rings slide into the motor mount, we will epoxy them.
Okay, all right, and that's just fine.
So we'll use proline epoxy. It's the standard that we used last year
right,
too.
Right.
Rocket epoxy is out of stock, I believe, everywhere still.
Yeah. So I'm sorry. What epoxy are you going to use instead?
Proline epoxy.
Okay.
So we'll just use proline epoxy on the top and the bottom. Same as we did last year, pretty much for our 10K build.
Yep.
Yeah, go ahead. Sorry.
I say I'm not telling you what to do, but I would score the inside of that aluminum, up so that I would rough up the inside of that aluminum ring so that it adheres well when you epoxy that to the motor tube.
Yes, and we actually made this diameter of the rings a little bit bigger than the outer diameter of this.
Okay.
So we could when we slide it in, we can have a little bit of just a little bit of space, so the epoxy can run through the inside of the ring.
Okay. All right. So then it looks to me that your transition, this piece that's missing, I can imagine you're actually transitioning up to a larger diameter instead
Yes.
of yeah. Okay. So before we get there, if you can go back to your the fin can there and help me understand the rail button that will be attaching the rocket to the rail.
Yes. So this was actually I remember your first email.
Yep.
You basically told us to just go the plastic route on the rail buttons.
Correct. Yeah.
So the compromise that we came up to was to design these standoffs that are about the difference in height between the two diameters.
Yep. Yep.
So we will have 2 rail buttons in the back. So one closer to the back in between the fence.
Yep.
And it will actually be threaded onto one of the rings too.
That's a good idea.
And since we have these centering rings too along the rocket, we will actually secure the other one to the middle.
Okay.
Right here.
All right, and then the aluminum piece that you showed me, that is the correct height to hold it away from the rail so that your payload section, which is a larger diameter, clears the rail.
Yes.
Yep. Okay. Perfect. Yep.
And we also chose to put a third rail button on the forward airframe.
Yep.
Just to make sure that this airframe doesn't go in contact with the launch rail.
Okay. Yeah. That's interesting. You are the third rocket that I've reviewed in the past week that has 3 rail buttons instead of 2. And there's nothing wrong with that. The only thing that I will caution you on is when you just use 2 rail buttons, it's a little more forgiving, because no matter where you put those 2 buttons, it'll be a straight line, and so it'll slide onto the rail, quite easily. When you use 3, it becomes hypercritical that you're lining those buttons up really straight. Otherwise, you're going to have binding on one of the buttons. So I don't know if you have a piece of 1515 rail available to you that you can test that to make sure that it slides freely. But for sure they will have a piece of rail available at the safety review in Las Cruces.
We actually do, because we
Okay.
actually had to design a launch rail ourselves. So we do have a large enough rail. No, it's fine. It's okay.
Okay, fantastic. That's it. You see what I'm getting at? That when you have 3, they need to be perfectly lined up. If you just have 2 and one's off a little bit, well, the rocket will sit, maybe not even noticeable, but it'll the point between 2 buttons is straight. But between 3, it's up to you to make sure that you precisely put those. So. Okay, that's all I need on rail buttons, and thank you for your. I think those look like they're Darylin buttons. As I mentioned, aluminum on aluminum can cause galling, and that can be really bad. So, okay, so I can yeah.
No, thank you for the notes. We will take it down and be careful when we choose to where to put the third, or if we even put the third.
Well, the last thing you want to do is waste that precious thrust, because you have a button that's sticking on there, So you need all of that to get where you're going. So okay, so kind of talk me through then after the transition to the larger diameter.
So the transition has 9.8 inches in length, or in height. It sits completely flush with both airframes. It has a 2-inch shoulder on both sides.
Okay.
And we'll use what I believe are 10 bolts on each one of them, top and bottom.
Oh, okay. So that's a fixed location. It's not going to separate. Okay, and that's why you can use a 2-inch shoulder, because it's not movable. Okay,
exactly. So
very for the clearly, you've read the DTAG. That's good.
Yeah, for the nose cone, I don't know if you can see it, but it does have the
an entire caliber.
I think it even has more than this diameter, but it was just to be safe.
Sure. Okay.
But yes, so the transition is going to be, I believe, 9.8 inches in height, 10 screws around securing with the shoulder, on the shoulder. And that's going to be the last piece before we go into the forward airframe.
And that'll be just like your other rings that it's threaded, and you'll just be turning the screws right into the threaded aluminum.
Yes. So
okay.
we actually made the transition thick enough so it would allow it for good enough threading, so that the screws would have enough thread.
Okay, very good.
Then moving on, so we have the forward airframe. So this is where our avionics, recovery, and payload will sit. We'll have payload in the back, avionics up front, with recovery sent from the shoulder all the way to the top of the nose cone. We'll also have some, I believe, 1414 shear, shear pins.
Okay, how many?
So we'll have 4. It was
Okay.
We made the calculations together with recovery to know exactly what were going to be the forces from the Raptors.
Okay.
And it came out to 4.
Sure. And then I imagine with everything else that you're testing this week, you also have some ground testing planned to make sure that those charges can adequately deploy your chute and separate the nose cone.
Yes.
Okay. Okay. Fantastic.
And then on the inside, actually, last year we had a problem in assembling on site at Spaceport, which was we were basically freehanding where the avionics bay and the payload bay would go. So we were just basically trying to figure out where the screws were and to match the holes. So this year we decided to just 3D print basically what we call a rail. I will just epoxy it to the inside, so it'll allow us to just slide the payload.
Okay, you'll just slide in, push up against that, and then you know exactly where you are. So
exactly.
Yeah. Okay. That'll save you a little bit of stress out in the desert. So
Yes.
Okay.
I would say from us, unless you have any other questions.
Just remind me, I did read all of your stuff, but you got to remember I've reviewed a lot of rockets, and so I'm
Yes.
trying to keep in my head which one was it. Tell me a little bit about how you're switching the power on to your systems.
I will let avionics take care.
Alejandro, you there? Can you hear me, Alejandro? Oh, there we go.
Yep, he just had to unmute his mic. So yeah.
Okay.
You want to go ahead and review with us about the pin switch and also the remote start? I can review about the remote start system for payload. Oh no, payload's also here. But you want to go ahead and brief us on how it works?
Oh, just the pin switch? Okay, so
Yes, sir.
all right. So we're pretty much using a similar system that we used from last year's rocket from the 10K. The pin switch is pretty simple. Part of our circuitry, we're using 2 telemegas. One is the main one and one is the accelerating one. And they only turn on once we remove the pin switch, because there's 2 switches, and then we have a small narrow metal rod that we put in inside of the rocket. So during the competition, while the other sub teams are preparing the rocket, the flight computers are safely turned off.
Okay, so when you have to remove the pin to power up.
Yes.
Okay. And when you pull that pin out, what causes the inside of the switch to make contact? Is it yeah? I mean, because I'm imagining that pin is holding something apart, and when you pull it out, it's closing the circuit, correct?
Yes, that's correct.
Okay, so what is holding those 2 pieces of conductive material together after you pull that pin?
My sub team, we designed a little 3D printed canister that's made out of PLA.
Okay.
So just to clarify, they're actually limit switches. So they have the little lever part inside of that 3D printed canister that they're mentioning. And
Okay.
so when that pin is actually inserted, that limit switch is actually pushed down and it's held down by the pin. And so we wired it in a normally
Oh, so it's
um,
normally
open-
closed. Yeah, it's
normally
a push,
closed, correct.
like a push
Oh.
button normally closed, and the pin is that you're having there is depressing it so it's open.
Correct. So when we remove the pin, that's when the circuit actually becomes completed, and the lever is released on the lever switch
Okay.
or the limit switch.
And so the travel of that push button is perpendicular to the direction of the G forces on this rocket.
Correct. So they
Okay,
were actually
okay.
the opposite. So they don't get moved by the force of the acceleration.
Perfect. That's what I just was, you could imagine that'd be a really bad situation, because I think I heard something like 23 Gs or that you wouldn't want the boost of your rocket to turn off your systems. So okay, I'm good with that. You might have to explain that to the safety reviewers. And you say these are switches that you manufactured?
The switches are bought. We didn't actually make the actual switch. The only part that we manufactured is the housing for the pin and the switch assembly.
Okay, all right. Uh, if that isn't easy for the person who's reviewing the rocket to see, I mean, I'm imagining that's like inside a housing or something like that. If it's easy for you, I would print another one, so that you would have something so that they can visualize what you're doing there. So, because I've been in that room before where you're looking at a finished rocket and they're telling you what's inside there, but you can't see it. And so if there's any question on that, I would just print another one.
No problem. We actually have a few extras on hand, so we'll
Okay.
make sure we
All
take
right.
those with us.
Well, then just bring them with, right? You don't have to. You're already done. So okay. All right. And then you tell me about the power source, your batteries.
Okay. So for the power source, I previously mentioned that we're using the telemegas.
Yep.
From the flight manufacturer itself, they recommend, if I remember correctly, the lithium-ion batteries.
Okay.
Or
Oh, you mean the LiPo? Do they? You're reading the battery instructions correctly. That they're sort of banning LiPos unless the manufacturer is specifying them.
yes.
Okay. All right. So um, commit that requirement to memory. Be able to recite that to the people for the safety review. So
Okay.
okay. Yep. All right. Okay. So just give me the timeline again, like when you think you'll get your final parts and when you think you'll have a fully integrated rocket, and then when all the testing will take place.
So at least on the side of structures, I can I think we're the ones that have the biggest delays.
Mhm.
So we hope and we believe that by the end of next week, we will have all the pieces that we need to complete the rocket. And since we have the test launch scheduled for either next Friday or next Sunday, we we believe that we can make it at least to one of the dates.
Okay, so
To test launch the
May
rocket.
24th, because I mean that May 24th is
Yes.
when you're thinking you'll have the parts, or is when you'll be able to do your testing.
I would say at least on the part of structures. Andres would probably be able to say on the whole team, but either the 24th or the 26th, I would say.
Okay.
Right now, just to add on that real quickly, the biggest, as Pedro said, the biggest work that's cut ahead of us is definitely structures. Apart from that, the second biggest part on the list is definitely recovery. Just in terms of their testing, I know they've been practicing the entire semester on, the assembly and all that, but we still need to do the nose cone now that we barely got the nose cones. So we need to
Mhm.
do a nose cone ejection test to make sure the Raptor CO2 system is working as it should. But apart
Okay.
from that, we should be pretty good to go.
Okay. So just stating the obvious to make sure you're aware of what's going on. If May 24th is kind of an important date for you all, that's the beginning of Memorial Day weekend. So the following Monday is a holiday. I don't know if that would conflict with any of your plans or your ability to do testing and stuff like that. But just throwing that out there so you're aware of it.
Yeah, we'll
Yes.
keep that in mind, and we'll make sure we communicate that with everybody. But for the
Yeah.
most part, it will mostly be the critical personnel will be the officers.
Okay.
Anyone else, we will try to get the whole team, but the most critical will be the officers to be in attendance at a minimum for that test.
Okay. Because then after that weekend, just a few days and it's June, and and then the event is starting to breathe down your neck. Now, I don't see that as a problem. You are not the only team that has a rocket that isn't fully integrated yet. If you can imagine, if you had supply issues, imagine, like the teams in India and places like that, because they're buying from the same suppliers as you. That other people don't have fully integrated rockets yet. But just from a safety standpoint, if you start having to rush, near the end, that's when there's going to be accidents. Is when you're pushing or rushing to get things done. So I guess watch that May 24th and see if you can get the parts to fully integrate the aerostructure itself. Then everything else should be able to fall into place. So.
Yeah. So the plan here is once we collect pretty much or retrieve all the missing parts, whether from the FedEx or the people who are pretty much giving this thing to us, we're gonna make a list hopefully this coming week and understand how close we are to the 24th, if we can actually have this. Because once we have the whole plan, I need to talk to the people in Horizon who work and give us the FAA waiver, so we can say at this date, at this specific time is when we can launch.
Uh-huh.
And once we know this, then we will see, hopefully 24th, but if it is, to push it, I don't know about 26, because maybe people in Horizon might have plans for Memorial. But worst case scenario, if it's not 24 or 26, then 31st should be the Friday. That will give
Okay.
us a couple of weeks pretty much.
Okay.
Yeah, but the
Fantastic.
idea is, so the idea, we don't want to rush this. We want to do things safely and also enjoyable for people in the team and for our department, because I know that there are local news coming and people, it will be an event. So we want to plan this, as best as we can get.
Sure. And I will also, I do safety for a living. I'm actually the director of EH&S here at Iowa State University. And I kind of pay attention to where accidents happen. And one of the common themes I see with accidents is they happen late in the day or after dark and things like that. So if you find yourself pushing into the evening, that's probably a really good time to look at each other and say, tomorrow's another day.
Yes.
Yeah. Okay.
I agree. Yeah.
Yep. Okay. Fantastic. Before I cut you loose, do you have any questions for me?
I don't think at this time. I think the only thing we right now that we're looking at is, getting this test done. After that, really, there's not much other than the other preliminary safety review after this one, right?
Yep, right. Which will, like I say, some people will get through it on that Monday at the convention center. Other people will get it done on Tuesday. I won't be in the convention center on Monday. I'll be on the campus of New Mexico State University. ironically, teaching a course on rocket safety. But then I will definitely be there on Tuesday. So I was going to say, just look around for a bald guy in a blue shirt, but that's kind of everybody in Ezra, so yeah, so
Yeah.
I'll sort of blend in with the rest of them, but but anyhow, good luck. Be safe, be careful, and we'll see you in June in Las Cruces. So be sure to collect the recording that you have, and there's an email address to send that to, so that they can collect that and put it in with the rest of them.
I appreciate your time, William. Yes,
I appreciate yours. Thank you very much. I'll mark in on the judging that we have completed this task.
yes.
So, all right.
We're gonna keep you posted. Hopefully, whenever it is 24, 26, or 31st, to see how we went into the testing flight.
Sure,
Just
fantastic.
updates.
Yeah.
Sounds good.
If you have video, I like say I love rockets. I mean, it's not anything you'd be judged on, but just curious. So, all right. Thank you very much. Yep. Good night. Bye.
Bye bye.
Bye-bye.
Thank you, guys.
Thank
Thank
you.
you.
Bye bye.